A characteristic of big data is that it involves formats with diverse structures. That is true. One of its traditional sources is business processes. Now it claims that this is false because we have seen in the video that the non-traditional sources of data are individuals and the other one out of the three, business processes, is one of them. But business processes can also generate traditional data as well. So I'm not on board with the answer for this one. Just because it was listed as one of the non-traditional sources, business processes, does not mean it cannot be part of the traditional sources. Much like individuals were listed as a non-traditional source of data, but also a traditional source of data as well. Real-time communication of it is uncommon due to vast content. No, low latency data is more and more common. Low latency, which is real-time or near-time data. So this is wrong. They want to go with A, but half of B, I think, is correct. The other half incorrect if you take a reading of the section that talked about non-traditional sources. Which of the following statements is true in the use of machine learning? Some techniques are termed black box due to data biases. Well, there are some terms that are labeled black box, but it's not due to data biases. It's due to the fact that you're asking an algorithm to find structure in the data. And it reports, hey, I found this structure, but the question remains is, well, how did you find that structure? That's what they mean by it's black box. Human judgment is not needed because algorithms continuously learn from data. Well, no, you do need human judgment. You need human judgment in the type of data that it's going to see to begin with. And once the model has been determined from the training data, and you validate it, then you need judgment to determine, well, is it overfitting, is it underfitting? So human judgment is still involved. So we got to get rid of these two. We got to go with the third one. Training data can be learned too precisely, called overfitting. Yep, resulting in inaccurate predictions when used with different data sets. That is a true statement in the use of ML. Text analytics is appropriate for application to large structured data sets. Well, you can start with an unstructured data set, which is just the text of a speech. And text analytics would look for certain words within that and try to derive meaning out of those particular words. And then that meaning would then be fed into a decision, whether to buy a stock or not buy a stock. So we can get rid of this one. For public but not private information, well, you can use it on both public and private information as well. You can look at a chain of emails across an intranet, intercompany emails, to see if there's any nefarious type of communication going on and try to identify the source of it, right? Identifying possible short-term indicators of coming trends. Well, yeah, that's what you can do, right? You're going to analyze this text and you're going to come up with some kind of meaning for this text. And some of that meaning could be, well, does it signal a change in policy, perhaps? Maybe you're listening to a Fed official and you're looking at previous speeches and you analyze this speech and the algorithm says this is distinctly different. The message is distinctly different than the others. So, sure.